तो नेक्स्ट जो आर्टिकल है वो है हमारे पास प्रॉपर्टीज ऑफ वेव फ्रंट। इन द लास्ट लेक्चर वी स्टडीड अबाउट वेव फ्रंट्स। Wave fronts are of three types, that is spherical wavefront, cylindrical wavefront, and plane wavefront. Now we will study the properties of wavefronts, which some of from which we have already studied. First property is about the energy of flow. Energy of light flows normal to the wavefront. Energy of light flows normal to wavefront. It means if we make, for example, your spherical wavefront, so it is part of spherical wavefront. If it is wavefront, then energy flows normal to this wavefront. So we can say that energy is flowing towards x-axis, and wavefront is along y-axis. So wavefront is always in perpendicular direction to that of the energy. So this one is the first property. सेकंड प्रॉपर्टी जो हमारे पास होती है, we can say that if there is some source of light and light flows uniformly in all the directions, so that is known as the isotropy of space. So we can say that in each direction light travels equal distance in equal interval of time. If velocity of light is c and we see the wavefront after time t, then if this one is the wavefront after time t, then radius of this wavefront can be written as ct, that is distance from the center of the source up to the wavefront. So we can say that radius will be c into t, because c is the velocity of light and t is the time. So distance is equal to velocity into time. In the same way, we can say that in each side of the wavefront, radius will be c into t. So we can say that at each point of the wavefront, distance from the source, that is point source, is same, uh, or in other words, we can say that if there are number of particles on this wavefront, then from these particles which are on the wavefront, distance of origin from these particles will be same which are lying on the wavefront. So this one is second property. Now we will talk about the third properties. According to third properties, spacing between different wavefronts. So if we make a large number of wavefront due to a point source of light, so all these wavefronts will be spherical, and these wavefronts are made according to time. So when time is t1, first wavefront will form. When the time is t2, second wavefront will form. When the time is t3, third wavefront will be found. So third property says that spacing between different wavefronts will be constant. So spacing between first and second wavefront, spacing between second and third wavefront, spacing between third and fourth will be. Now after that, the fourth property of wavefront is phase about phase difference. If we talk about phase difference, then we see that each point lying on the wavefront have same phase. So we can say that every particle when lying on same wavefront, then each of the particle have same phase. So we can say that phase difference between each particle lying on the wavefront will be zero. There will be no phase difference between particles lying on wavefront. And fifth property is same as we have talked about in point number 1, that is a line perpendicular to the plane of the wavefront give the direction of propagation of the wave or direction of propagation of the energy, and this propagation of line which shows energy is known as the ray of the light. So this is the ray of the light, and the ray of the light is always perpendicular to the wavefront, as we have already uh, said in point number 1. And next point also we have already studied, that if from the point source we watch some wavefront at infinite distance, then it looks plane wavefront. So if distance is less from the point source, wavefronts are spherical, but as we go away from the source, then this curvature of the wavefronts minimize and we get a plane wavefront. So we can say that at a large distance, a spherical wavefront becomes plane wavefront. So if the distance is very large, then wavefront will be wavefront. So we also say that shape of the wavefront, shape of the wavefront depends upon shape of the wavefront depends upon source, types of source. As we have already studied that single point source emits spherical wavefront, a line source make cylindrical wavefront, and a point source at very large distance make plane wavefront. So shape of source decide that what types of wavefront will be formed. Next, we will study about Huygens principle. Huygens principle. So we have already talked about different theories put forwarded by various scientists. First, Newton says that uh, light consists of corpuscles that is small particles, and to propagate light, requirement of some material is essential, and he called that material as he took the idea from the radiation. He said that as some requires some medium for the radiation, similarly light may also have some medium that is known as the ether. But after Michelson-Morley experiment, Michelson-Morley said that there is no existence of such ethers. And after Huygens, uh, Maxwell and Fresnel described various phenomena like interference, diffraction, and polarization by using Huygens wave theory. Huygens himself describes reflection and refraction. Reflection and refraction were described by Huygens himself, but interference, diffraction, and polarization. These concepts are described by Fresnel and Maxwell, but they use the same theory to explain these concepts of Huygens. They used Huygens wave theory to explain these effects. So, what the Huygens wave theory says? Huygens wave theory says that he described his wave theory with some points. And first point was that a source of light in a homogeneous medium like ether sends out the waves in all directions. As the wave carry energy, so energy is transmitted in all directions. He says that if there is some point source, from this point source light emits in all the directions. And these waves which are this light which is emitted by point source travel through some medium, that is the ether. Again I am saying that idea of ether was later on rejected by Michelson and Morley. So Huygens said same thing which earlier Newton had said, that there exists some medium that is ether. So this was his theory's first point, that is the light uh, travel in each direction from the point source, or that may be some another source. It may not be only point source, it may be cylindrical source or plane uh, source of plane wavefront, or a single line source. And main point was the second point, that is the main point of his theory, and that point I will explain with figure. If there is some source, then this source of light emit the light, and the light flows in each direction, and we can make any wavefront, and this wavefront will be near to the point source, so it will be spherical. He said that this wavefront is taken as P, and we call it as primary wavefront. So he said that he can anyone can select any of the wavefront as a primary wavefront. Then he said that PQ is the primary wavefront, and each point on the primary wavefront, if we take a large number of points on this primary wavefront, then each point on the primary wavefront acts as a source of secondary wavelets. So each point, I have taken only a few points. If I take each point on this primary wavefront as secondary wavelets, so we can say that each point on this primary wavefront act as a source of light, and each point is again a point source, and there will be spherical wavefront, and these spherical wavefront are very small, and we call it as wavelets. And if we take envelope for these wavelets in the forward direction and in the backward direction, then these envelopes are called as secondary wavefront. Secondary wavefront. So we can say that primary wavefront is a source of wavelets, and these wavelets are source for the secondary wavefronts. Then again, if we take points on secondary wavefront, then there will be produced also secondary wavelets. Points of primary wavefront make primary wavelets, and points on the secondary wavefront make secondary wavelets, and these secondary wavelets make tertiary wavefront. So in this way, we say that light travels in forward direction. There is also secondary wavefront in the backward direction, but we ignore the backward direction of the light, because light travels in forward direction and we do not care about the backward direction. So this was his theory, in which he said that a point, each point on the primary front is a source of secondary wavefront, and each point on the secondary wavefront is source of tertiary wavefront. So in this way, wavefront spreads. When the wavefront spreads, the intensity of light goes on decrease. As we move away from the point source, the light goes on, the intensity of light goes on decreasing. After time interval, secondary wavelets give rise to near wavefront. So we can see that in the first attempt we take primary wavefront, and that makes secondary wavefront. So in that way we call this secondary wavefront as new primary wavefront, and that new primary wavefront again produce secondary wavefront. So in this way light goes on propagating from the point of source. After the Huygens theory, we discuss about the Maxwell's electromagnetic Maxwell's electromagnetic wave theory of light. Wave theory of light. Although Fresnel modified the Huygens wave theory of light to the extent that light is propagated as transverse wave in the hypothetical medium ether. So in the same way, Fresnel said that light also requires the medium for the propagation, that is ether. But Maxwell doesn't say that light only propagates through ether. He said that light has transverse nature. As we know that sound has longitudinal nature. He says that light has transverse nature and it can propagate without any medium. So he doesn't say about the idea of ether. To explain the propagation of the light through it the main obsession was about the nature of the ether. So if there will be some types of medium that is ether, then this ether can have some finite rigidity. So due to this finite rigidity, that rigidity will affect the motion of planets and satellites. So the idea of the ether was later on dropped, and said Maxwell proposed a theory which not only required the light waves to be purely transverse but also linked with the variation in the electric and magnetic field. He said that the electric and magnetic field variations occur when the light propagates. So, for the propagation of the light, variation of electric and magnetic field is must. He presented a paper on his wave theory, that is electromagnetic theory. He worked on this theory by taking the different equations proposed by Faraday, Henry, and Ampere, and he presented all the equations, that is the equations by Faraday, Henry, and Ampere, and these called his equation as Maxwell's equations. But these equations are already derived by another scientist. So with these four equations, he discussed his theory in detail, and he said that accelerated charges produces disturbances, and these disturbances uh, are affected in electric and magnetic field. The light waves are also electromagnetic in nature. Maxwell's electromagnetic theory of light waves does not meet the objection regarding the concept of ether. So, concept of ether was not included in the idea of Maxwell. So later, the idea of ether was rejected by Michelson and Morley. So, in it, we will further study about the electromagnetic waves in the next lecture.